Hey YouTube, what's going on? There is the pick of the week with Daniel Dallas. So today we're gonna go through indices and you'll be able to answer this sort of question, which is greater, which number is greater, 2 to the power of 500 or 5 to the power of 350. And we'll also be able to solve this nested root and calculate the exact value for that. Alright, grab your pen, grab your notes, let's get started. So first of all, that's about comparison of numbers. So how to compare numbers? So the standard approach here is just to line either powers or bases. But have a look. 5 and 2, they can be made as one single basis which is the same for both numbers or for both expressions. So that's why we are not able to make comparison. That's the same for the powers, 300 and 700. We cannot, they are not equal, so we are not able to make comparison. How to work out with great powers if you're not able to align bases? Okay, so you need to try make external power as much as you can, but you need to align the powers, the maximum possible powers for two index or indices. So let's get started and just use the indices properties so that power in the power we can rearrange simply as 5 cubed to the power 100. So we made 100 as the maximum possible power here. What about 2 to the power 700? We can make in the same manner. So 2 sevens and to the power of 100. Now we see that powers, external powers, the same. So that if I mark 5 cubed as A and 2 to the power 7 as B, we'll get expression sort of A100 and B to the power 100 as well. So powers are aligned, so that's why you can make comparison of bases itself. Let's do this. And 5 cubed is simply 5 times 5 times 5. So that means you'll get 125. And let's compare that with A, which is 5 cubed. And what about B? Is 2 to the power 7. So B is 2 to the power 7. And if you know, like 2 to the power, not 3, but let's say 2 to the power 5, it simply means 32. If you times 2 again, you'll get 2 to the power 6. And you'll get 64 then. And if you times one more by 2, you'll get 128. That's 2 to the power 7. That's what is intended to get. So now let's compare it. So you have 125 to the power 100 versus 128 to the power 100 as well. So obviously 128 is greater than 125. So in power in any common power, like 100 here, that will be the same. Inequality keeps fair. So that's why in general 5 to the power 300 is going to be less than 2 to the power 700. Alright, so I hope you got it, how to do. And let's go to surds. So that's why surds are basically irrational expressions or rational numbers. In this case, square root of 2 is, so it's nested. It's nested in every following expression. So that's why, and how many terms? There are infinite number of terms under the square root because it goes on and on. How to work out the exact value for this? The hint is in the following. So if you express your unknown as x, you can say that if you square up both sides, you'll get x squared equals 2. So in this case, we eliminate the external root, which is here, and we'll stay with 2 plus, and again, square root of 2 plus all other nested square roots, okay? But, however, because there are infinite number of terms, you can say that this expression the same as the original one. So you can say that this is just x. So what you can see that you'll have quadratic equation x squared minus x and minus 2 equal to 0. If you want to solve that, you can factorize in this way: x minus 1 and x plus 1 and x minus 2 if you do factorizing, or you can use quadratic formula to figure out. So, and we've got x1 value, which is -1, and x2 value, the second value, is 2. So obviously we have the square root and it's always positive, so we need to say that x is going to be more or equal than 0. So in this case, we choose only x equals 2. So that's why the exact value for this expression, x equals 2. This method actually you apply when you're trying to convert, let's say, periodic number like 36 in the period, so like that, into the fraction. Almost the same approach, into the fraction. So you can easily do that by saying that this is x, and if you multiply by 100 in order to get, again, 36 as the whole, and 36 what you had before, like 36 is decimal part or fractional part, you'll get 100x from there. So that's why you can subtract. So if you consider it as simultaneous equations, so you can subtract and get basically 99x equals to completely fair whole number 36, because decimal parts that you have here, there, and there, due to subtraction, they annihilated. So basically you eliminate the fractional part completely. So that's why the final answer is going to be x as 36 over 99. Okay, so actually I used the same approach by inputting variable, and that's how I can get a value for a rational expression like this. So I hope you understand this, and just I want to show you a presentation. So let's say we have only one square root of 2. So that's around 141, right? So basically number of 2's, it will lay out how many number of 2's. We'll get just only 1 2 and under the square root, and that's why value for square root of 2 plus square root of 2 plus the same, like it continuing process, that's the value. It's a vertical axis, and number of 2 is horizontal, so we've got the first point corresponding to what if we have only one square root under the square root. So 1 2 under the square root, and the value, well, we've got a 1.41 approximately. What if we have 2 2's? Okay, let's take that square root of 2 plus internal or nested square root of 2. If you use calculator, you'll get around how many? Approximately, you'll get 1.85 to 2 decimal place. So that's why if we have 2 2's on the square root, we'll get sort of that value. So this point actually need to be a little bit down, so it's right there. So that corresponds to the value 1.85 approximately. And what about the value 196? Obviously, that's going to be when you have 3 nested roots, and the result, if you use calculator, approximately is going to be 1.96. So that's why for 3 2's, you'll get exactly this number, which corresponds to 196. Okay, so that point is going to be here. So by doing this process continuously, you understand that soon you'll come to the line with value 2. So that's the line with value 2, and it's right there. So this is dashed line. So the more number of 2's nested in the expression you have, the more closer, or the closer you get to this dashed line with value of 2. So it's sort of asymptote. However, here we have not smooth graph because number of 2's is a discrete value, so something in between we cannot connect with lines. However, even for discrete numbers, it's sort of like sequences, right? Or the sum of nested twos, you can consider as the sum of the terms. It will approach 2 as the asymptote. So this line is the asymptote for your expression. So finally, the exact value will be 2 when number of 2's is very, very close to infinity. All right, so hope you like that. That was pick of the week, and I found it pretty interesting for this week. So guys, enjoy, try to get to the point, and stay tuned up.